So I would like to introduce our next speaker. He's well known to the Lyme community as the Director of Sales for IGeneX Incorporated. Mr. Bob Giguere has been involved with clinical laboratory medicine since the 1980s and is well versed in immunology of tick-borne disease laboratory medicine. He's been with IGeneX Specialty Laboratories for the past 10 years, and there's a great deal of debate about the complexities of laboratory testing for Lyme disease and other tick-borne diseases. So we look forward to his presentation. Following Mr. Giguere's presentation, there will be a question and answer period. Please give a warm welcome to Mr. Bob Giguere.
Well, thank you again for inviting me again. I appreciate it. And thank you for the eloquent introduction. And of course, I'm going to try to build on some of the great work of the local group here under Dr. Dorado and take you from the entomology through the lab work and then put you into the very good hands of Richard Horowitz and Dr. Strum this afternoon. Okay, so let's talk about Lyme disease and making sense of the testing, because we in lab medicine have done a heck of a job of making it even more confusing for your clinicians. And I'm going to work at trying to explain why we've done that, or the excuses we have come up with from everybody from the CDC onto my lab. Okay. So my own background is, of course, in molecular biology. I didn't come here to train it, thank God. You get Lyme disease, it seems, any way you go around this campus. So I don't know if that's a reason to keep the kids in class, telling them they can't go outside, but maybe it works. So let's talk about Lyme, and I'm going to, again, take some of the eloquent work and try to build on it from my two previous speakers. So I was at the CDC out in Fort Collins about 6 months ago. A good friend of mine retired from there, a kid who learned and actually did really good in molecular biology inside Cambridge where I was. And he went off to become under Willie's Dorfer's protege. And I was there for his retirement. Interesting enough, he gets to retire and I got to keep working. So at the CDC, they now know of at least 6 species that can transfer diseases. And yeah, there's a 7th one down there in the bottom. That's the Orthodontous Hermsii tick, and guess what? It transmits a strain of Borrelia, not Burgdorferi, but another strain of Borrelia that you're going to be seeing if you haven't already. The mention of the woolly rodent was very apropos, as I gave a talk about a month ago out in Illinois, where they are now finding at the University of Chicago a significant number of rodent carrying ticks that carry Lyme. There we go. Okay, at the CDC, this is a slide from these guys, and my friends show me now we know of 14 different diseases that are carried by this bug, and it's an ever-growing number. And along with that, of course, you saw that the size of this thing is very small, and like Dr. Dorado, I can't see him anymore. I've got to get my better glasses or something. So we know they're out there, we know they're moving around, and they're getting worse. Now, you heard a little bit about this. The eggs, of course, the 1,500 to 3,000 of them being pushed out of a female into the larva stage. Then they become, of course, looking for their first blood meal. And we all know this guy. This is the white-footed mouse you were hearing about. And at any one time, 15 or 20 ticks at least will be attached to this. So they will love to pass on Lyme and give each other everything they've got. So the ticks all in this early nymph stage, or even if they attach again as adults, will pass it on. So these are the other major vectors we're now finding a lot. Birds, squirrels, of course, and other things that you mentioned about, all moving things around your yard and in the grounds, taking around the ticks. And this is usually what happens in the second phase after they become nymphs. They're looking for a bigger animal, like all young adults. They're looking for something more to eat. And they go attacking one of these. And one of the things we found out from the U.S. canine population is that where we find over 15% of dogs affected by Lyme disease, and you heard that from my two previous people about how bad it's getting, there is a strong correlation, almost absolute correlation, of the presence of Lyme and the growing epidemic that's happening wherever they're catching a lot of it in the animals, especially the dogs. So these are major vectors now. Yeah, that poor guy's got a palsy on his left, and the cat's not too happy about having Lyme either. So I always put up this one to wake up my residents and scare them to death. And yes, whatever you've got out there that will move, a tick will attach to. I'm terrified of snakes, but this one I do feel bad for. You're over 46 minutes here. Okay, and it's sucking. So, but of course, as we all know, this is the big vector. This is mass transit for Lyme disease, and it's actually the cruise ship that the males and the females go on to meet and fall in love. So, at any one time, one of these wonderful animals will carry at least 300 to 400 ticks, and they will be carrying them around with them for months to a year. And when they do that, they join together, they fall in love. The good news that you heard earlier was that it seems to not be a major vector for the transmitted disease, the deer, but we have a problem, and it's the Miyamotoi strain. The problem is that Miyamotoi, which was published on about 4 years ago by Krause et al. In the New England Journal of Medicine, is in a significant number of ticks now. I was at the Vector Lab up in Maine about 2 months ago, and in the fall it was already in 18 to 20% of the ticks up there. The Miyamotoi strain is transferred from mom to all, or a significant number of his offspring. So, unlike a deer chick, which has to drop off and get it from something else, this guy gets it, or this female gets it from mom. So it's literally going to go from 1 to about 1,000 to 1,500 ticks that are going to get it, and it's going to be, it already is a serious issue. So, what can we do about it? Well, look, I'm not advocating we kill every deer in the United States, but I am advocating we need to cut it down. We have a real problem here. 100 years ago, there was a nice ecosystem, as Amanda presented to you earlier, and the ecosystem showed there were less than 1 million deer in the entire USA. That's according to the U.S. Department of Agriculture. As you all are probably aware, in 1918, it became illegal to shoot a deer anywhere near a house. In 1954, we all know a guy named Disney made it socially unacceptable. And so now we got 35 to 40 million of these guys running around spreading their oh God, aren't they beautiful, with a whole lot of things coming from them. So, how bad's your population in New York? Well, you got almost 1 million deer. Congratulations, you are really great helping them grow. You could lose about 25% to hunting, another 70,000 that are reported at least being killed by collisions, and there are countless others that die just of starvation because there's just too many of them. And with it, of course, you saw this slide already, and yeah, it's getting worse. This is a slide you didn't see. Again, this is presented from Paul Mead, the head of the CDC, at a conference I was at Mass General a while ago. And this is where it's going to be in 2018 and 19. And yes, the red is what he said is going to get worse. So, welcome to Lyme Central. New York State has the highest number of reported confirmed cases, according to your department down the road in Albany. Here is, you already saw a lot of this data. Remember that the CDC says an epidemic is 25 cases per 100,000 of any disease. You're doing a heck of a job with this one. So, and not to be left out, of course, you got passed by Pennsylvania last year with over 9,000 confirmed cases, and it now leads the nation. So I guess in your race, I don't know if you're a Bills fan or a Pittsburgh fan, but we'll see. So, why is this bug so hard to stop? Okay, my background is a little in molecular, so I'm going to talk to you about why. This bug is smart, and it's big. Syphilis is significantly less. It has less than 7 genes on it. This bug is 1/4 the size of your genome. This is a big, very smart bug. It has 123 genes we know of, and at least 26 plasmids that we've found and the CDC has found so far. What that means is it will outsmart virtually every immune system it finds. If you don't find it and kill it quickly, give it time, it will find a nice way to hide and stay within its host and continue to live and prosper. So, some of you saw this last year, and that little, this is actually Borrelia burgdorferi in a mouse trying to dig its way out of the blood system. And what it is using is its spirochetal shape to drill out of the blood vessel of a mouse and get into the tissue. This is not Steven Spielberg work. This is actually the work of a friend of mine up at the University of Calgary Medical Center. And it shows that Borrelia will go into the cyst form when it gets out of the blood, because where is it going to try to hide? Not in the blood, because if you've got an immune system, you're going to go after it. Your immune system's going to try to kill it and remove it. And so it's smart enough to know the best place to hide is in the tissue, and that's where it's going to go.
Okay, so let's arm the mice. That's what we need to do. I know that the NRA is having their national meeting today in Dallas. I probably should have been there telling we should arm the mice, forget the people. But we're not getting guns because they don't grow old enough. So we now know that there are 37 known Borrelia species that can be in your body at any one time. So that's a problem because not all of them cause Lyme disease. As a matter of fact, so far we only know of 7 that actually have a severe problem here in New York for sure. And we need to talk about those. And I am going to talk about 2 in length, the Miyamoto and the Hermsii. The others are probably coming along, and we'll be carrying some of these and transferring some of the diseases that we see, such as the Americani. I think is going to be the next one, or the Andersoni. So, Immunology 101, what your doctor learned in the first week of med school and probably forgot, was that in the first couple of weeks after an infection, the bug comes in, your what you call dendritic cells see it, and you mount a quick immune response, which are T cells and NK cells. Then later on, your B cells take over and they produce a nice strong immune response, it's IgM. And then later on, to supposedly protect you forever, is the IgG response. And so at any one time, you've got a lot of IgG for a lot of different diseases floating around in your body. So, Lyme disease is a clinical diagnosis. We say that all the time, especially if you're in a lab, you want to say that because we know how bad the testing is. So, early symptoms, yeah, if you got the rash, 40-30%, whatever, fatigue, headaches, all those wonderful nondescript things that happen to us every day if we're out there in the real world. One of the things Joe Burrascano used to always say was that take the person's temperature around 3 in the afternoon. If all they have, not one of the co-infections, but just Borrelia, they might have a temperature about 101 to 102 in mid-afternoon, yet subnormal in the morning. Later on, you're going to see disseminated disease where it's affecting your joints. It's not arthritis if it's moving. If it's staying in one place, congratulations, it's arthritis, and we can take care of that with steroids. But if it's moving, it's not arthritis. And of course, we know about the neurological issues that Lyme. A lot of children get that because of the affinity of Borrelia to the facial muscles. But the cardiac involvement was noted by the CDC to all board-certified cardiologists about 3 years ago when they sent out a letter to them all in the U.S., which, of course, probably made the circular file. But they should have been read, is that if you have cardiac involvement in your patients and you cannot explain it in an endemic area for Lyme, you better be testing for Lyme disease. Now, we all know what the rashes look like. If you got this, it's Lyme 101. Do not allow your doctor to do a lab test. Okay? At this time, there will not be a positive test unless your doctor doesn't like you and wants to do what we call a puncture on you, or a skin biopsy, where they're going to take a piece of skin with a scalpel or with a needle and then do a PCR technique on it to find the Borrelia. At no time is the person going to be producing enough antibodies when the rash is showing to actually produce a serology test, the ELISA screen that they want you to use, or a Western blot. And this patient did not have a positive serology yet. We did do a puncture biopsy. I don't know if we didn't like them, but we did do a puncture biopsy and we did get a positive PCR. So again, no serology positives, PCR positives. So what do we got? We got common symptoms, and these all show up coming and going. And the problem is that your doctor does what they were trained to do, and what they do for virtually every other test in the world, and that is look at you, make a clinical, and do a lab test. There's a problem, as it shows very pointedly here. How dare you have this with your symptoms? Get out. So, not all rashes are Lyme disease. Okay, so if it hurts and is scaly, congratulations, it's probably not Lyme. So why do we test then? Because everyone with MS would rather have Lyme disease. They don't. We also know that we're getting really upset with the bull we called chronic fatigue or fibromyalgia, where all of the nondescript patients seem to be getting pushed by most medical people now. And some of these people do have these diseases, many of them do, but in endemic areas for Lyme, to avoid the possibility that it's Lyme is really, I don't think, appropriate. Let's make sure the patient's getting the right treatment. So, where did all this confusion start? Back in '94, when I was trying to run a laboratory outside University of Connecticut, I and about 400 scientists, including Dick, Dr. Tilton, the dean at UConn, Ray Ryan, the head of our laboratory. We were all invited to a meeting in Dearborn, Michigan, with a lot of other docs, about 400 of us from research and teaching institutions around the United States. At that meeting, and if any of you are real overachievers, the Library of Congress has the entire 400-page written of this in their library in Washington, D.C., and you can call it, and they'll probably get you a copy, and it's really nice light reading for the evening. I'm going to give you the shorter version, let's just say the Cliff Notes of what actually went on there. During that meeting, they decided that we were going to take out 2 of the bans for Lyme. I'll talk about those in a minute. And that the laboratory confirmation has to be a 2-tier approach, like we were doing at the time for hepatitis and HIV. Well, those are great because the tests work. With Lyme disease, because the tests are so bad, we actually stood up at our table from UConn, because as you all know, we couldn't sit with the guys from Yale. But Alan Steer actually stood up too, and actually, bless his little soul, Gary Wormser actually stood up at the Westchester County table, and we all said the same thing to the CDC. These tests don't work. So they fixed it. They called it surveillance criteria, which is not to be used for clinical diagnostic purposes. So that ELISA test, this titer test that you get, followed by a Western blot, was proven by the CDC not to be used for clinical diagnostic purposes. Now, at the meeting in Mass General, and again up in Fort Collins where I was, Paul likes to show this slide now. I call it the hubbada. Let's dance around the question issue. And it actually shows, as Amanda showed earlier, you're missing the iceberg. You know, we're looking at surveillance criteria at a very small percentage of the known positives. So we need to be a little more careful. Now, I always put this one up now because I was at another meeting with a friend of mine, Alan McDonald, who's a pathologist who actually knows what's going on. And I was semi-falling asleep during the presentation by Dr. Beebe. And Alan gave me a nudge. He goes, hey, whose blot is that? And this is a CDC slide with an IGeneX Western blot on it. Okay? So, I went back and looked at how has the CDC changed its ideas on how you diagnose Lyme. Well, if you look at the front page of the report that the doctor's supposed to push in, or the laboratory, you can see that it says what it's supposed to, but you got to turn it over. And then go down to a case Lyme definition, and I've taken that word for word and put it down there. This report is to emphasize epidemiological case definition only. It is not for clinical purposes. This is the newest report. You can all download it from the CDC website if you have some burning desire to. So, what happens to your poor physician who ends up getting stuck in the middle here? They get the test back that's not accurate, or really isn't, and they look at it and they go, oh gosh, now I got to choose. Am I going to take on the IDSA, as good men like Dr. Strom have, and stand up and say, no, I'm going to take care of my patients? Or are they going to buckle under to the old school and not believe that it's chronic Lyme, it doesn't exist, only needs 1 to 2 weeks of antibiotic, low dose, and you're cured after that. It's a post-treatment syndrome, so you can just treat the symptoms, which pharmaceutical companies tend to love. Treating the symptoms is better than curing a disease. So, because you can do it forever. So what we have here really between these two groups, because there is a rip there that's been going on for a number of years, forcing your poor primary cares and your other doctors who see patients into a big it's a situation that can cause them all kinds of issues. And we have a failure to communicate. So what I tell people now is it's a physician's challenge is to take at least Richard Horowitz's EMSIN's questionnaire, fill it out, and maybe then you'll have a little more belief that what you're looking at actually is Lyme disease, even when your initial test was. So, evidence-based medicine, because that's what I hear from infectious disease guys all the time. I don't believe in IGeneX, and I want evidence-based medicine. Okay, I can show them 700 peer-reviewed articles that show Lyme disease exists long-term. I don't know, and these are from everything from the New England Journal of Medicine through all of the major journals in the United States, even through the Lancet. I don't know what more they need to prove Lyme exists, but 700 peer reviews kind of tells me, maybe it does hang on. So we're going to delve a little bit into the immune system here so I can explain to you about the testing that you're getting and why some of it works and some doesn't. Your body has an acquired immune response to an infection, okay? It either has a T cell, an initial response, and then later on you get your B cell, which are your antibodies starting to produce. And we're going to delve into the use of both of these in the diagnosis of Lyme disease. Now, in the laboratories in the United States and other places, we have a bunch of different techniques that we can use, and most of them are for indirect testing. That means we're looking for your body's response immunologically to the presence of the bug. Excuse me. Some of the times we're going to be doing some of the direct tests, which is actually looking for the bug itself, such as done in the laboratory here on the ticks with the PCR, and can be done on humans, of course, also. Problem with the testing you've got. Well, I've only been doing this since 91, I guess. And we have found over the years that the tests that you get, screen tests, the titer, the eyes, work anywhere between 50 to 70% of the time. And if your HIV testing worked like that, it would never be allowed on the market. So why is that so? Okay, this is the lab, this is the 96-well plate that we use in a lab to do an ELISA, a screen test, a titer test, whatever you want to call it. Into those, we put, into each of those 96 wells, we will put antigens that we think are specific to the bug we're looking for. Then we will take your serum and we will pipette it down into it. And what we're trying to do is get that wonderful little antibody that if you've been infected with Lyme, you should have running around in your body, to attach to the antigens that are specific to it in that little tube. Problem is, like the symptoms of Lyme being very similar to others, so are the antibodies. So what happens is, if the patient has a number of other infections or has had some other things going on, which every one of us has, they're going to compete for the limited number of what we call binding sites on those antigens. And when they do, they don't form strong immune complexes. When they don't form, the next step after that is to wash away anything that isn't bound. Well, if you don't have a nice strong immune complex formed, you're going to have an issue with the inability of the binding to give you a positive lab test. And it's not the fault of the technique, it is using this technique in an inappropriate disease. So that's what we formed, those nice immune complexes. You wash away everything that's not bound, so anything that's partially bound, you got to get rid of that, and voila, you get a negative test. Now, it's not just me saying that these tests don't work, okay? This is the College of American Pathology. That they found that these tests don't work, you shouldn't be using them for clinical purposes. This is your own Jennifer Halsey up the road in Albany 2 years ago at the primary care doctor saying target antigens are not necessarily the ones we're looking for. And if you've had a vaccine, antibiotic therapy, or any other responses, you're going to have potential to get a negative test. Yeah, like everyone in the world. So, the most recent study we've got on these kits that are used shows, this was a nice study done about a year and a half, 2 years ago in International Journal of General Medicine. And the biggest tests that are used across the United States and into Europe all use ELISA kits that work about 60% of the time. So there is another technique that was originally developed by Alan Steer after he ruined the prices of homes in Yale because he was a resident in Yale. And he named this thing Lyme disease. He developed it down there at Yale and at St. Raphael's, and he used an immunofluorescent test first before we did the ELISAs. And what we do is you take a slide, you throw the bug on it, wash the person's serum across the top, and hopefully that serum, if it's got antibodies, will bind to the antigens. You get a nice formed immune complex there, hit it with a second antibody that looks only for that immune complex, voila, it glows, and you got a positive test. Well, specificity is pretty good with this. Sensitivity, probably even better. You may get some false positives with it, but it's better than what's going on. And of course, in your state, in New York, you can't use this test. So let's talk about confirmatory testing and the ones you can use, which I want to see, I'd rather see people use rather to screen for Lyme disease, because getting the right answer 50 to 60% of the time really doesn't help many of these. Okay, it's the wrong way to go. So a Western blot, which is what everyone hears about, what it is we take the antigens that we think are specific for the disease, put them in a bath, throw in this acrylamide gel, and what we do is it forms a mold where you've spread all the antigens around it, and so they're nice and homogeneously spread. Then we put it, take that Jell-O, put it between two pieces of glass, stick it up on its side, put 8 slots down. In slots 1 through 8, and 1 and 8, we put controls or standards from the CDC or the NIH. 2 through 7 you usually run patients. Every Western blot is run this way. Then we hit it with a positive charge at the top. What that does, besides gravity pushing those antibodies that you pipetted in from the patient down, it also, positive charge of those antibodies makes them want to get away from the heat at the top. So they run down. And I always tell people, you know, the thinner, healthier guys can run down through the blot, but the bigger antibodies, they get tired, they don't want to go anywhere, so they just stop. And so we actually have spread them out by molecular weight doing that. When we do that, and you turn off the power and you lay the thing down, all of the antigens near those antibodies that you spread that match them will combine with them and form blots, bands rather. And what it is just an immune complex forming between the antibody of the patient that relates to the antigen of the bug. And that's where you get these bands. So you can see in this 1 in 8 are controls, 2 through 7 are patients, and you can see a lot of different variations in all of the patients coming down the blood. Now, back in 1993 and 94, when we were at the Dearborn, Michigan meeting, we knew some of these bands meant something to Lyme and some of them didn't. So since that time, we have now related all of these different antibodies to Lyme disease. Now, the ones in solid green, most of the time are Lyme disease. A couple of them are absolutely specific to Lyme, but not all. And back in 94, in the Dark Ages, I guess, I'm not so sure we're out of the Dark Ages there, we didn't know what it was going to mean, so the CDC had a couple other ideas. They said, well, look, all of these antigens don't always show up with one strain. So you can try, the one strain you probably should use is Willie Bidorfer, which has been published in Nature. That was the one that Willie Bidorferi is the B31 strain, and that is used in every kit in the United States. That is FDA approved and used at every laboratory. Be it the Mayo, be it Quest LabCorp, or your hospital, they are going to use either the Mardex blot or the Meridian blot, and it's going to be the B31 strain. I won't bore you with how we harvested that, and it did the 510K submissions, because yes, we did the 510K submissions, so I have a pretty good idea what went on in that blot and what we did to it to make it work really quickly. Westchester Group had been doing a lot of work with the N40 strain. That, of course, included Dr. Spear's work out of Yale and others, and they had eloquent work. And then the 297 strain, which is the ones out of Golightly's lab at Stony Brook. Again, lots of articles and written on it, a lot of research done. So in '94, the CDC said you can use any one of these strains. ASTAFELT is the Association of State Territorial Public Health Lab Directors. Again, this is all in that 400-page document if you have some burning desire to spend a week. So here are what IGeneX does. This is a blatant kick for us. We don't just use the B31 strain, we use the 297. Having two strains means you've got a good expression of all the proteins of interest on the surface, so you'll get a better presentation of what the patient's actually seeing at any one time. But the other thing that happened at the meeting in Dearborn was the removal of two of the most important bands. So the test you get here in New York from your major laboratory or hospital does not include the two most prominent bands for Lyme disease of the 5 that happened. Well, that's pretty cool. Why did they do that? They did that because some of you may be old enough to remember there was a LymeRix vaccine. Came on the market in 1997. Went off the market in 2002 because, of course, SmithKline said that no one wanted it, but there were other reasons. And bioMérieux never finished the development of their RSV vaccine, so it never got to the market. But taking out 31 and 34, those two KDA proteins, caused a significant drop in the specificity and the sensitivity of the test. So now that's not just me saying it, okay? Here is a recent article from Gary Wormser saying many laboratories omit these. Yeah, no kidding, and they are specific for the Lyme spirochete. This is an article from the American Journal of Medicine 3 years ago. 4 now, I'm getting old. So if he's willing to say it, one of the most conservative infectious disease rheumatologists in the country, well, you don't know who Gary is, I don't think, and I do. Okay, so what does the CDC done? Well, the CDC continues to say, use 2 of 3 for an IgM positive. We include 31 and 34. Stony Brook includes 31 and 34.
And those are the only 2 laboratories in the United States anymore that do our own in-house assays. There is a laboratory in New Jersey that uses a European strain, includes 31, but it's not an American strain. They're using the Afzelli strain and doing a Western blot off of that. And I question the capabilities of that strain. And honestly, it's proven to not work real well. So this is the IgM where you supposedly have an active infection. Now back in '94, they said, hey, we don't know what's going to happen, so let's pick 5 of 10. So these are the 10 that the CDC says, if you got 5 of these, you got Lyme disease. And I know Dr. Horowitz will probably talk about Lyme bingo this afternoon because he wants to look at these. And bands 31 and 34, they do not include them in the presentation of the test you get. That reduces the specificity and sensitivity of this test that you get to make a clinical diagnosis on a tough case to 50%. It's like, oh, I got to make a decision on this patient. Looks like Lyme, feels like Lyme. Let me do a lab test to confirm what I'm doing, and you're going to use a test that works best 60% of the time. That isn't much help. Now, early on, Alan Steer, now he calls this post-treatment Lyme disease. It's not. What he saw early on, published in JI, Journal of Clinical Investigation, and repeated by a lot of other doctors, not just his one study, show that Borrelia over time will change its outer surface presentation. And when it comes, it's protein presentation. So over time, when it comes back out of the tissue, instead of expressing, say, 23, 31, and maybe 41, all of a sudden now 39's on its surface, and 83. And now your body's immune system thinks, oh my God, this is a new bug. I'm not seeing the same thing. Now they're giving you another IgM response, because that's what it's supposed to do. Well, there's a high probability it isn't a new bug. It isn't a new infection. It's just a reactivation because you weren't probably treated appropriately to kill the bug the first time. And how, well, I know this guy isn't in Boston, but he is at the University of Kentucky Medical Center. And he first coined this and calls it, and it's called quorum sensing. It's the Borrelia, not just B. burgdorferi, but any good Borrelia spirochete can do this. It's the ability to change its surface proteins, and we call it quorum sensing. So over time, as the bug defends itself against the immune system that you try to throw at it, it will go into hiding, it will come back, it will change its surface presentation, and you'll get new IgMs. If you're going to your conservative physician that doesn't believe in chronic Lyme, they're going to call this post-treatment Lyme disease syndrome. You've got IgM, and this is the only disease of the thousands of the infectious disease guys work with that doesn't supposedly cause active infection when you see IgM. That makes no sense. So, we have a new problem though. Not only do they not want to pay attention, we got a new boy in town. And this one's going to be a real problem. As I mentioned, the Miyamotoi strain is going to grow by leaps and bounds. Instead of going from 1 tick to maybe 5 or 6, 7, 10 ticks on a mouse, it's going from 1 mom tick to 1,500. And the new strains, we call them tick-borne relapsing fever because the problem here for relapsing fever is that it's being missed. Lyme disease sensu latu, which are the strains that are very similar to Borrelia burgdorferi, include Lone Starrii, which used to be called Masters, the 2 European strains, and a few others, the Pacificus, that you don't see here yet. Hopefully never will. But there's also relapsing fever. Perm.CI is moving here. I was at the CDC. It is an epidemic in the western part of the country. And Miyamotoi, it's here. We're picking it up in 15 to 20% of the ticks in New England now. It's in New Jersey. It's big time in New Jersey. In New York, it's coming up. And Miyamotoi is one of the tick-borne relapsing fevers. The other 2, Dutani and Pacari, are both from the south, one from the southeast and one from the southwest. But they all tag along sometimes. And we are actually seeing people now coming back positive, not only for burgdorferi or one of the sensu latus, but one of the relapsing fevers also. And here is the most recent data on ticks for tick-borne relapsing fever. And even though this says from Tom Schwann, again, my buddy who just retired and I can't, from the CDC,
it was interesting. I was up there talking with him about this. He gave me the slide. I went down the road to give rounds at the university down in Boulder. And those of you who have a little bit of geographic area know this is about 25 miles from Fort Collins. When I gave rounds, not anybody in the meeting that I was at had any idea that there was anything called even known as Hermsia. And it is an epidemic in their state. So I kind of said to them, it's kind of interesting, you know, they're only 25 miles away. You can almost throw a rock and catch them. But you should at least talk to them once in a while. So, is it getting worse? Miyamoto infection is spreading. Someone asked the question of Dr. Grotto about other birds carrying it, or turkeys. Well, guess what? 2009, the University of Tennessee found Miyamoto in over 58% of the turkeys at harvest. Back 9 years ago. You can imagine how bad it is now. You know, yesterday I left here and I saw all these geese out on your wonderful lawn out there doing things. About 6 months ago, I gave a talk up in Toronto to the Canadian medical kind of guys that run the labs and stuff. And boy, they didn't like the idea when I put up a picture of their Canadian ghost and told them that their Department of Health told me that about 3 million of them come to the US and come back and forth every year. And as far as I can tell, they haven't vaccinated or tested one of those geese. They just let them fly. So I tell them that the geese go down to Florida for the day or for the week, and this winter they spend spring vacation, get in trouble with the police, then fly home to Canada to avoid prosecution, but they bring back things, and it isn't just a ticket or a memorial from lovely Miami. They're bringing more things. So, Lyme disease and relapsing fever look alike, okay? Here are the major symptoms: fever, fatigue, and headache, and it looks a lot like Lyme, B. burgdorferi, Arini, and these are the only two strains that they tested it against. But these symptoms, all again, look the same. And Brian, right down the road in New York City, has even said this and published on it. The problem is they're going to miss it. Doctors are going to think it's Lyme, it's going to look like Lyme, it's going to feel like Lyme. They're going to test for it. And even if they do a good Lyme test, which they probably aren't going to do, we're going to miss it if you're sending it just a Lyme test to IGeneX. It's not going to pick it up. There isn't a lab in the country that will just test for this. Now, there is a laboratory that's licensed in New York to test for Miyamoto. Immugen out of Newark, okay, that's a kick from my competitor. They are but re-advised. Be very careful here. It is the only strain of relapsing fever that they test for. And it's available through Quest LabCorp, but the problem is it only looks for one of the strains. And the Miyamoto may be here, but I can tell you the Hermsii is in Toronto and up along the northern coast, just over into Canada, and it's moving east. I'm picking up Hermsii all over Illinois, and again, I'm talking Tuesday in Cincinnati, where I'm going to have to present data from their Department of Health on the Hermsii showing. So it's getting worse, and if you test for Lyme, you're going to miss it. So in Pennsylvania, not to be left out, the task force simply reasonably said, wouldn't it be nice to have tests that have an accuracy of over 95% with sensitivity and specificity? Yes, it would be nice, and we're working at it. Not as quickly as we'd like, but we are trying to stay ahead of the play by offering a specific immunoblot. Now, the difference between this and a Western blot is that we actually use, much to my heart, recombinant proteins, which are very, very, very specific to the specific gene disease we're looking for. So, as I mentioned to a couple of people before, you get cross-reactivities in Western blots. 31 crosses a little bit sometimes. We know 41 does with everything, but even 83 and 23 we found over the years to cross over from Epstein-Barr, Chlamydia pneumoniae, and that's one of the reasons your doctors will tell you you don't have Lyme even with a positive Western blot. They'll say, oh no, it's just the Epstein-Barr. Not anymore. They can't pull that anymore. We've got a protein-specific assay that is DNA specific. It will not cross. When you get a band 31 with our immunoblot, it didn't come from anything but an exposure to Lyme. Same with all the other 5. So, if you were exposed to it, it'll show up in most of the cases. How good is this test? Sensitivity-wise, right now, according to the CDC, because we had to prove a lot of things to them, they came to our lab, and then they came back again because they couldn't believe how good our data was on their samples. And they came back and we kept proving to them that this thing seems to work. So we've got a sensitivity now of a test that's over 92% and a specificity of this test approaching 100%. This is a very, very, very accurate test. So we're getting there in medicine, trying to give a test to your doctors that actually is specific and will not cross with the Epstein-Barrs or the chlamydias or even the hepatitis. It won't cross anywhere. But there's another thing that we can do as we move forward. We have all tried to use PCR for years, near and dear to my heart. Yeah, I sat there with boys at MIT figuring. But those are horrible days. But now we've got other things we can do cellularly. Not just look for the serology response, the response that you're used to seeing in the lab tests. So what we've got here is what your body does. Is the first thing it sees when a tick comes in, or bug comes into the body, into that little bubble of blood under your skin. The first thing it does is let go NK cells and T cells, which will attack the bug because they'll attack it because you've got what are known as dendritic cells, which are right below the skin. They see this foreign subject, they grab it. We call it ingesting it. They take it, tear it apart, send that data to the lymph nodes. But while it's sending to lymph nodes, it immediately starts to activate T cells. T cells at the site, right there, fast. And what they do is they become what we call mature, specifically going after this new foreign bug, and they will attack it immediately at the site of the bite. Okay? Now that's nice for early Lyme, very early. We will see a T cell response. And there's a lot of data out on this thing that the first week post the bite, you may get a positive test in this, maybe the first 2 weeks, but then it gets cut down. Why does it get shut down? Well, your immune system starts to take over. And when your immune system and B cells start to kick in, the T cell response starts to get pushed down. There is significant published data that interleukin 10, which is one of the cytokines which forces your body to continue to grow immunologically and produce antibodies, that gets shut down by Lyme. When Borrelia shuts that down, your body's immune system starts to stutter. It doesn't work well. All of a sudden, those co-infections and other things that you've got in you that your body has been keeping in check start to run amok because there's nothing there now because your body's immune system is trying to do something that it's being stopped from doing. It's getting hit, and hit hard by the less number of interleukin 10s. You've got another group called the T regulatory cells, which actually in your immune system try to keep everything working in symptom. When it sees your interleukin 10 drop down, it immediately shuts down your pro-inflammatories to try to keep everything in balance. And then this circle just keeps getting worse and worse. Now, I'm going to mention something called CD57s. Lab Corporation of America does a pretty good test here with this. We do an OK one too. If you've got to do a CD57, please don't do it by any other labs than those two. Most of the other laboratories all use a mathematical equation to give you this. They don't actually measure CD57 NK specifically. You should know there are over 300 CDs now that we know about in the United States. CD57 positive NK seems to be reasonably specific for about 80% of the cases of Lyme. And you notice that I'm being very cautious about this because it is not an absolute measure of Lyme. It is an absolute measure of your immune system in most cases. Be advised, I've seen people in wheelchairs with a number of over 300, and I saw a guy who ran a marathon and his number was 30. Low numbers mean your immune system's a mess. What's going on here? So it isn't only Lyme that affects this cluster. So here is the more telling piece that we've got for the T cell response. As I showed you, the Borrelia goes and hides in the tissue. When it comes back, again, macrophages from your body are running all over all the time. They're in your blood. They see this foreign object enter into the bloodstream again. When they do, they act like the dendritic cells. There are a lot more of these. And they actually will grab this new bug, encapsulate it, tear it apart, of course, and then put its parts on its surface and start to develop an immediate T cell response
the release of interferon gamma through the T cells. Now, that means that an active infection is now here because you've got a T cell response. Now it's going to send data back to the B cells, to your lymph nodes, to develop an immune response by antibodies, but the initial phase of active infection at this phase will not be affected to the extent that your B cell response is being affected. Remember, your immune system's already being suppressed, okay? But the T cell response isn't being so effective. You'll have NK cells that attack it, and you'll have T cells. So you will get an immune response with this test. The question becomes, is it active? Absolutely. For years in neurology, we have known that a T cell response is active infection. T cells live for 4 to 6 weeks. So if you're producing a Lyme-specific T cell response by interferon gamma release, you absolutely have an active infection. If you don't have that positive T cell, it's more than likely not an active infection. At IGeneX, we actually took some of Dave Datweiler's work and Alan Steer and developed a test using 6, again, recombinant proteins that we know only release interferon gamma during an active infection of Lyme. So we took those 6, put them in a tube, we put your T cells in there, and we got this thing called the spot that forms down at the bottom when the interferon gets out there. Because what it does is those 6 recombinant antigens force your T cells to release, if they are mature T cells looking for Lyme, they will release interferon gamma, which will pick up immediately and put a spot on you. And that shows active infection. So, when is it good? Late in the disease, people always ask me, and I get this every day. I got a patient who got treated for Lyme 3 years ago. They may still be producing antibodies, but they all want to know if they're cured. This test will only tell you if it's active infection. And I'm warning you right now that this isn't the perfect answer. But what it will do in a person who walks into the office 3, 4 years down the road, whose immune system may or may not be working well, it will give you the doctor a complete picture of not only the B cell response, but the T cell response specifically to Lyme disease. So it's an excellent tool. Again, the disadvantage is you can't use it alone because if your antibodies are present, your body will shut down T cell response. So you won't, so what I'm saying is that if you've got IgM and you got IgG floating around specific for Lyme, this test is more than likely going to be negative because your immune system knows not to let everything run amok and it shuts down the T cell to let the far more specific long-term IgM and IgGs do their job. So, now that I've totally confused you, I'll try to unconfuse you with a little bit of direct testing. That's PCR. Okay, and there's a couple different things we can use. Fish testing, which is fluorescent in situ hybridization. That's looking for the RNA. RNA is live part of a bug, so if you get RNA positive from us or from Stony Brook or from NYU Medical Center to Borrelia, we don't do it for Borrelia, but we do it for Babesia and Bart, and they are licensed here in your state now. If we do get a positive for one of those, guess what? You got active infection. Because I've had doctors argue with me about the co-infections of Babesia producing PCR positive and telling me that that isn't live bug. That couldn't be. It could be, but more than likely is. So, let's talk about PCR. PCR, because you hear about it all the time, what we do is, if you watch Big Bang Theory, you've seen this on the back wall. And that's my favorite show. I was a geek too once. You know, I still am. So what happens is we take that DNA, that strand, and we got great names for it, molecular, because we want to confuse people. We denurture it. All that means is we take the 2 strands apart. Then we got it apart and we use cutting enzymes. We use ACO1, we use a whole bunch of different enzymes that are like scissors. And they will cut that DNA in specific sites, very specific, along that DNA strand. Then we take and throw that pieces into a thermocycle. Henry Ehrlich won for this. Okay, it's a long time gone. But when we throw them in, we also threw in primer sets. Primer sets are sticky pieces of DNA that will attach to both ends of specific sequences of DNA from the bug. And what that means is one goes on one end, one goes on the other end, and the thermocycler makes an exact mirror image of what's between those 2 sticky ends. So you got a 3 and a 5' end. One cycle brings you, makes 2 of them. 2 cycles makes 4. For HIV and hepatitis, your laboratory will do 25 cycles. IGeneX, we do 50 for Lyme. And we use 3 sets of primers. Virtually every little lab in the United States, other than the CDCs, which you can't send samples to, will only use 1 set of primers, which were published on back in 93 or 4. And we use 3 sets at IGeneX because we're looking for not only genomic PCR, but for plasmid. So the chances of getting it, I'd say about 60%, 70% of our positives for Lyme and PCR are from plasmid PCR. It's because the bug is smart. What it does while it's still in cyst form will break off plasmids. Plasmids are little pieces of specific DNA that stick off that thing, that cute little thing. And you'll throw it into the blood system to see what happens. If it gets a response from an immune system, the bug doesn't come out of tissue. It stays there. If it doesn't see anything, then the bug will come out and have a party time running around your body, finding new places to extra live. But plasmid PCR, there's a lot more of it out there in active infections, but still not a lot. There are labs that tell you a PCR, and if you don't have a positive PCR, you don't have Lyme. That's a lie. But if you do have a positive PCR, and I don't really care which lab you use, if it's a CAP-accredited, CLIA licensed lab, if they get a positive PCR, it should be due to Lyme disease. I have a problem with one laboratory that's come out with very short pieces of DNA. Remember I showed you there are 37 different species now? On that whole strand of DNA, there are a lot of what we call conserved regions. That means this piece of DNA, be it 3,000, 4,000, 6,000 base pairs long, appears in all or most of the strands, all the different species. When you cut this thing up with enzymes that cut it too short, less than 1,000 base pairs, you are opening yourself up to picking up non-specific Borrelia. They're not Lyme disease. And you'll get a positive lab test. So if you just want a positive PCR, yeah, that works pretty cool. But if you're trying to be specific, you better keep that base pair length at least 2,000 and not be using conservative reasons. So you got to make sure. Now Quest, LabCorp, the major labs don't do that. They all use one, they do a pretty good job with it. But again, it's only going to appear in our hands and at the University of Connecticut's hands when we were doing this. And I was working with a group at, I had a laboratory in Gaithersburg, Maryland. When we were running that PCR, even with one band, we were still only getting positive rates in active infections of about 20 to 25%. So it's not the end of it. It's very specific, but the sensitivity is related to the bug's ability to hide. So what do you do with all this stuff? Well, if you're in Pennsylvania, you can do a lot of things because you can order all of our testing. But in New York doesn't want to believe anybody else. They don't want to believe CLIA. They don't want to believe California Department of Health. They don't want to believe the 49 other states that have departments of health that run labs. So they make doctors conform to only the tests that they have run in Albany that they find appropriate, that they have blessed. Now that's a problem because they don't believe anybody else, and that slows down and confounds your poor physicians because they are not available to them. They can't do the best testing. I actually had a doctor ask me where he should practice, and I said, 5 miles over the border into Pennsylvania. So this is where I tell you people, we have a dot blot was developed at the CDC back in '91 by Tom and his group. I didn't talk about that for time-wise, but the IgX spot is our new baby, and it works really well for very, very, very early Lyme, but at about 4 weeks it goes away. So do not use it if the person comes in and has had the tick bite a month ago. You've already got antibodies being produced, probably IgM on the way up, and there we should be using a Western blot, maybe a PCR, maybe an ELISA if you have to. The immunoblot is the best test at that time. And then going on a year later on, you got to look at everything. You got to look at the immune response, you got to look at the bug, you got to look at the T-cell response to try to figure out where this bug is hiding. So now that we've scared you all to death, let's talk quickly about how am I doing on time? Pretty good? I'll be done in a couple of seconds. I'll make this, because the co-infections, I'm sure Dr. Stram and Dr. Horowitz will more than aptly take care of. They're much more capable at these than I am. Just understand that all of these bugs live in the midgut, Borrelia and all the rest. The transfer wasp A to wasp C activates Borrelia burgdorferi in the midgut of the tick. When it does that, it produces from 500 to about 100,000 within 24 hours, pushes them right into the body of the host, and sucks out some more blood, and then pumps in a whole lot of other wonderful diseases that your body gets to have to figure out how to deal with. Co-infections across the United States have gone through the roof, Babesia being the biggest one. People are missing it all over the place, and I'm going to warn you about it now. New York State, found in all over the state, smaller than Lyme. This was 4 years ago. Okay, it's getting worse. So, almost? Okay. These are the last, I'll bore through these quickly. Anaplasma, if you've got a headache right behind your eyes and you got muscle soreness, you probably have the co-infection of Anaplasma or IgG. So any laboratory in the country can do a good job with this. I call those kits bomb-proof or idiot-proof, depending on your point of view. And so the kits work in anyone's hands. You get an Anaplasma positive or negative test from Quest, LabCorp, your local hospital, it's accurate. There are a whole bunch of different tests you can do, PCR, smears. HGE is the big one here, our Anaplasma, that's the one you really should be looking for. Babesia is the more problematic case because you've got two strains here. You've got Duncani and you've got McCarty, and your lab tests don't pick them both up. So the patient comes in with an air hunger, completely exhausted. They're coughing, they've got a dry cough, they need to take a nap every afternoon, and their headache is like a migraine. And I always warn doctors, make sure you ask them if they're taking that non-drug called Tylenol, because if they're taking Tylenol, their temperature is going to be normal, and you're going to miss it. Babesia is a huge issue. Its effect on interleukin-6 as a parasite is very strong. It will help reduce the immune system, and this parasite can kill you. So, in the United States, in New York, you have to require that your lab tests for both strains, both the Babesia McCarty and the Babesia Duncani. IGeneX, Stony Brook, and Columbia Medical Center now offer fish tests for this. Fluorescent in situ hybridization is RNA, as I said. It's active live infection, picks up all the strains. So we do a fish test. The best test, if you could get the pathologist to stop playing golf for the afternoon and read a smear, when the patient goes in there, you'll get a direct smear, and when that happens, that's what you see. It's called a Maltese cross. That's a person with Babesia or active, and if it's in the blood smear, good news. Even the infectious disease guys will defer and say, okay, we have active infection, when the pathologist calls up and says, hey, I got a blood smear that's positive, I'm seeing them, you want to come down and look at them? And the infectious disease guy will believe it and then start treating you for Babesia. The only other thing I'm going to mention quickly is Bartonella, cat scratch fever. If your hands burn for an hour or two, not 5 minutes. If your feet hurt. If you have tender skin nodules under your skin along an outer extremity, these are some of the major symptoms that we see with Bartonella. So, get to your doctor. You might have late night sweats, not the heavy drenching ones that we see with Babesia, but you may have others, and so you need to get some Bartonella testing. Be advised, the Bartonella testing in the United States is just a little bit better than what you're getting for your Lyme testing from the major labs, so we'd rather doctors see these. I hate to say it, this is Bartonella 101. This is Bartonella 101, why we call it scratch. And if your doctor doesn't practice 6-minute medicine but has the time to look at you, look behind their knees, look behind their shoulders, and guess what? You'll see these cute little raised red marks stretching. They're not stretch marks. They're going in a different direction. They're raised in red. That's cat scratch. Okay, and Rocky Mountain spotted fever. Well, when you get Rocky Mountain spotted fever, you're usually in the ER so quick it's scary because it's all over your hands and it's bumps and around. And good news is 2 weeks of doxycycline, 100 milligrams twice a day, cures it. So your doctor looks like a hero in this, unlike in Lyme. So the co-infection list keeps growing. This is just the numbers we've got today. I'll be back out in Fort Collins in 3 weeks, so we'll see how bad it's getting next year. Some of the bad things live in the woods, not just the dorms here at the university, okay? These are the guys that you got to see, and you can see them coming, but the one you can't see is the one that's going to bite you and give you the biggest problem. So I got to thank my friends at Calgary, and remember that the most dangerous test result you get is the false negative, and we in lab medicine have done a heck of a job of giving you false results and confounding your poor physicians. Thanks for listening.